This is video number 18 for chapter 12, the nervous system. And we're going to take a look at what happens at the postsynaptic membrane. So a neurotransmitter has been released, it travels across the synapse, and it reaches the postsynaptic membrane. So two things can happen. We can either have an action potential being generated, or we can have one being inhibited. So if depolarization occurs, due to the combination of neurotransmitters and neuromodulators that are released, then we have what is called a stimulatory effect, which is abbreviated as an EPSP, and that stands for an excitatory postsynaptic potential. So it's excitatory, it causes something to occur. If we have the opposite, hypopolarization occurs, so we do not depolarize, and I'm not going to write out due to the combination of neurotransmitters and neuromodulators, but then we have no stimulation of the postsynaptic membrane, and it's called an IPSP, which stands for inhibitory postsynaptic potential. So you can imagine if we have different pathways where we have hundreds of different neurons synapsing onto one other neuron, it's a combination of these excitatory and inhibitory that can cause a postsynaptic membrane, if it's another neuron, to reach threshold. So we have to look at some summations of these. The other thing that can happen at a postsynaptic membrane is something called an axo-axonic synapse. This is very common in the central nervous system. So here we have the axon of one neuron synapsing or synapses with the presynaptic terminal of another neuron. So there's a synapse at the presynaptic terminal. Here we could have a neuromodulator can act to inhibit or excite neurotransmitter release. So instead of it acting on the postsynaptic membrane, it acts on the presynaptic terminals of another neuron, and that can inhibit or excite that neurotransmitter being released to the postsynaptic membrane. That's called an axo-axonic synapse, and they're very common in the central nervous system. Now, summation. Summation is just a combination of graded potentials and action potentials at a postsynaptic effector. So we have a lot of different action potentials coming from different regions that can act on an effector. Whether it be a muscle, whether it be another nerve, whether it be a neuron in your brain that's receiving a lot of information from other places or from the same area in rapid succession. So it's the combination of all these things, whether they're EPSPs, IPSPs, that come together to produce responses in an effector. So we have two different kinds of summation, temporal and spatial. Temporal is when two action potentials arrive in succession from the same axon. So remember, temporal means time. So they're timed out. So we have one action potential from a neuron, we have a second one coming down in succession. So they can sum up at the postsynaptic effector, whether it be another neuron. Spatial deals with space. So here we have two or more action potentials coming from different axons. So this is very common in the central nervous system, where we might have input coming in from several different areas into one neuron. If some of them are excitatory and some of them are inhibitory, they can cancel each other out. If they're all excitatory, they will cause something to occur. If they're all inhibitory, they would cause it not to occur. So these summations help with integration of a lot of messages from different areas of the body. So these are just two different ways we can summate it, either in succession from the same axon or from different axons, spatial.